All right, welcome to today, guys. All right, there we go. Today's discussion is about one-to-one functions, onto functions, and inverse functions. One-to-one functions, this concept right here on a level of hardness is a 1. This concept right here on a level of hardness is also a 1. And this concept right here on a level of hardness is like a 9. All right, so here we go, one-to-one functions. One-to-one functions, I drew a little bomb because this will blow up in your face if you forget this. One-to-one functions have no y values that repeat. No y values that repeat. So let's go over something in our minds a little bit. Something is a function if none of the x values repeat. So I gave you a list of coordinates. Do they create a function? Oh, nice. Sweet. Is this function one-to-one? Do no y values repeat? Nope, no y values repeat. Whoops, made a mistake. Yes, it's also one-to-one. It's also one-to-one. And the way you could think of it also is, what did I say in my other classes? I said that these one-to-one functions are basically in monogamous relationships. Do you know what I mean? Yeah. In other words, 4 is madly in love with 1. 4 will never cheat on 1. You'll never see it paired with another number. Same thing with 7, same thing with 10. 3 is madly in love with 10. Even though 7 is a really sexy number, you'll never see it over here. You get it? One-to-one. Okay, we're good. A great question was asked. I said that 4 would be never paired with another number. What I meant was 4 in the y value. 4 in the y value. Let's just go back to my original definition that y values will never see repeated. All right, so let's play again. Part 2. Not part 2, number 2. We've got another listing of coordinates, and we've got to decide, well, do these create a function? Yes or no? Yeah, they create a function. Look, 2, 3, 4, 5, 6. Nothing's being repeated in the x value. So yes, it is a function. But is it a one-to-one function? No. No. It's not a one-to-one function. Now this brings up an interesting point. If you were looking at these coordinates graphically, right, how do you know if something is a function by graphically? It passes the what? The vertical line test, right? So when no x values are repeated, you're able to sweep your hand through and only hit once. If no y values are repeated, guess what it also passes? The horizontal line test. And so that's how you know if a function is one-to-one, is that if you can sweep your hand through this way and this way, in other words, if you can sweep your hand through, it passes the vertical line test and the horizontal line test, then it's a one-to-one function. Let's write that down. There we go, and this is what I mean. One-to-one functions pass both the vertical, because they're a function, and the horizontal, because they're one-to-one line test. Whatever gets to learn. Number two, onto functions. Remember I told you this is a level of hardness, this is a 1. Okay, onto functions. We put a little bomb. A function is onto if every y value is used. And what do we mean by that? You really need to look at a picture. So grab your calculators. And we're going to plug it in. We're going to take that first one, we're going to plug it in. We're going to do 3x minus 4. And we're going to take a look at a graph. And is every y value being used? That is a line. It goes on in either direction forever. So I would say, yes, every y value is being used. So this first one is an example of an onto function. Let me give you an example of something that's not an onto function. Take the other equation, plug it in. X squared minus 2. Look, there's a space. You see it? There's a space. Is every y value being used? Not onto. That's a big fat no. Because every x value is mapped onto a y value. That's why it's called an onto function. And if every y value doesn't get a mapping of an x value, then it's not an onto function. That's the real fancy math way of saying it, right? And you could do it with sets also as well. But the way that I've shown it to you is this is like the easiest, simplest way to remember it for this particular class. When you get into pre-calc and calculus, there will be a much more advanced meaning. It's just not very important for this class. Just understand the pictures, right? This was a line. This was an example of a line. And so every x value, every y value was going to get used. You see, the line was going to go on forever. So everything was going to get used in this direction. But this was an example of a parabola, right? And that's not the exact picture that was drawn, but that's okay. And so you had a huge space right there of y values that were not being used, so it's not an onto function. Okay, part 3, finding the inverse, the part that starts to get real difficult, real difficult. The inverse. The inverse is just what happens when you switch x and y. So here's an example of a bunch of coordinates. Can you find the inverse? Okay, let's do it. Yep, good job. Guys, what'd you say? Yeah. Yeah, exactly. Yeah. What? What? What is going on? Okay, all of a sudden, it went from being really easy to really hard, and that's what I mean. But this is no different. This right here, this business right here, is fancy function notation for inverse. And let's write that down. It's a real fancy way of saying find the inverse. It does that. This negative 1 up over here, this negative 1 up over here, that's not a negative exponent. It's more of a math grammar type thing, okay? This is function notation. It was developed by a man named Leibniz and a man named Newton who were trying to claim credit for it at the same time. And basically, it's a real fancy grammar way, they lived in different countries, of asking for the inverse. So let's go and find the inverse. Ay, 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 but how do we do that? There's not even there's no y in this particular case. Brewston? Oh, you're the man. Yeah, g of x is y. And in fact, that is step 1. Okay, so step 1 is to take g of x and instead write it as a y. And everything else stays the same. That's step 1, piece of cake. Guys, so now let's not miss out on the fact that we went dual screen for a reason, right? If you are given coordinates, how do you find the inverse? What do? What's written up on the board? Not flip it. You switch what, not numbers. You switch x and y. And let's use that same definition to find the inverse when you're given an equation. So what do you think step 2 is? Perfect. Switch x and y. Start recording. All right. Step 2. We're going to switch x and y. So where's my color? This right here is going to become x. This right here is going to become y. And technically that is the inverse, but we never leave numbers surrounding y, do we? So what do you think step 3 is in this big long process? Go. Step 3, if you had to actually give it like a name, if you were trying to write this down as notes on somebody else's paper, right, what would step 3 be? What is it? Yeah, isolate or solve for y. Let's do solve for y. I like that because we see that all the time. Solve for y. And let's do this. So we have x equals 2. Oh, come on, computer. X equals 2y minus 1. We're going to add 1 to both sides. These cross out. We get x plus 1 equals 2y. And then we're going to come back up over here. Right? We're going to get that. And that's technically the inverse, but we can't leave it like that. So we zoomed in. Step 4 in this big long process is write your answer using function notation. So there's our answer. What was our original function? Let's scroll back up to the top. Scroll back up. It was g inverse of x, and that represents the inverse. So what we do is we say in the end that g inverse of x equals x plus 1 divided by 2. Yes, you have to write that. You 100% must write that. Definitely. Okay. Oh my God, part B. Part B. This is where I told you where it went from a 1 to a 9. Okay. First thing we're going to do is, check this out. We're going to rewrite this and make it look nicer because that looks ridiculous. Okay. Always start and move from right to left. So that's g of g inverse of x. Now, how much was g inverse of x worth? Very nice. So I can replace the inside stuff with x plus 1 divided by 2. Yep. And we found that out from our other problem over here. Right? Take a look down over there. G inverse of x equals x plus 1 over 2. Okay. So now, we're going to take that, we're going to plug it into g of x. So g at x plus 1 over 2 equals, now how much was g worth? Yeah, g was worth 2x minus 1. So we got a 2, whoops, we've got a 2, and everywhere we see an x, we're going to put x plus 1 divided by 2. And then we're going to simplify. This 2 and this 2 cancel off. Then you're just left with x plus 1 minus 1, which is just straight up x. So g at g inverse of x is just this. It's just x. Okay, one more and we're out of this joint. Okay, here we go. What's the first step? Oh yeah, we got to rewrite that. Same thing as the other one, right? That's the same thing as me asking for g inverse. How much was g of x worth? I think it was 2x minus 1. Let's take that, let's sub it in. G inverse of 2x minus 1 equals 2x minus 1, right? Plus 1 over 2. Anybody confused about where I got that from? Where did I get the 2 from? All I did, in order to get this, in order to find what equation to plug into, all I did was go back to where we found g of x, and I plugged it in right here. So right there, at that x, right, I plugged in 2x minus 1. Okay, so let's go back down over here. Let's go back down over here. We're doing great work. I want you guys to know that. We're doing great work. So here we go. We've got 2x. These two 1s cancel. You're going to get 2x over 2. And what is that? It's just x. So g inverse of g of x is just x. And this is where we're going to end for today, because the whole point of doing this, right? If this was a short answer question on your test, let me explain what would go down. I would first ask you to find the inverse. That's this page over here. This would be worth 2 points. I'd then ask you to tell me, okay, prove to me that something and its inverse are what you say they are. And what you do is you plug them into each other. If you take the original equation and plug it into the inverse and get x, and then take the inverse and plug it into the original equation and get x, and you get the same answer. I'm talking about the same exact thing. The two are inverses of each other.